Hello, everyone. Welcome to an introduction to partial reconfiguration tutorial. My name is Bill Jenkins. I am a director of AI product marketing here at Achronix. What we're going to do today is just walk you through a high-level tutorial overview of how you would perform partial reconfiguration on our FPGAs. If you need to learn more about our FPGA fabric, there are many other trainings that we offer to kind of bring you up to speed on how we're a little different than other FPGA vendors. So let's start with what is partial reconfiguration. So if you think about partial reconfiguration, you think of the FPGA being a reconfigurable device dynamically while powered up. Unlike loading software, you're actually changing the hardware to represent what you're trying to do. So this provides that ability to partially change part of that FPGA fabric, reconfigure that part while the rest of it continues to work. So you can imagine you had to in the case maybe of AI, in the cloud or data center implementation, people want to swap different models out or different components within that image processing pipeline. So we can swap a function 2 for function 4 in this example. We can also, in the cloud environment, dynamically swap workloads. So part of the FPGA can be doing medical transcription, while the other part is doing financial predictions or object detection or one of those other workloads that are of interest. And you can do that dynamically, swapping one out for the other without the rest of it being affected. You can create functional libraries from those functions that get created, those partial reconfiguration functions, and then export them to be reused later. So there are really two methods that you do partial reconfiguration. The first is the partition import export method, which would be useful if you're creating libraries and then want to bring them back in. And we'll talk a little bit about why our architecture is a little unique and easier to use to do those kinds of things. But the method we're going to focus on today for this tutorial is a keep out region method, which is the recommended method of creating them. So the first thing I want to do is I want to explain that the fundamental difference to our architecture compared to competing FPGA architectures is that we have a hardware NOC, a network on chip, that basically 2D NOC runs around the entire FPGA core fabric and kind of disconnects the I/O ring from that FPGA fabric, making it much easier to get guaranteed high performance from connecting different parts of the device together. So data transfers up to 2 gigahertz give you about 20 terabits per second of low latency bandwidth. We also automatically manage the clock crossing when you're bridging clock domains. There's different modes to the NOC that can be used, AXI, streaming, or packetize. And the idea of this 2D NOC having kind of dedicated high-speed routing around the chip is it's going to simplify your congestion within the FPGA fabric to get easier timing closure with higher bandwidths. So if we look at our Speedster 7T1500, which is our largest FPGA we have right now, that FPGA fabric has 80 clusters. So those are arranged in an 8x10 architecture. Now, each partial reconfiguration region can only be built around those FPGA cluster boundaries. So you have to include the entire FPGA cluster as part of your partial reconfiguration region that you're going to create. Now, each fabric cluster contains one column and one row, what we call NOC access point or NAPs. So that's 160 connection points within the FPGA fabric to the NOC. Now, once we have these IPs, it makes it really easy to copy and paste from one cluster region to another within that core fabric without a need to replace and route or to recompile your design. So once you've closed timing on an IP block that lives within a partial reconfiguration region, of course, that's going to be on the bounds of an FPGA cluster. You can then scale your design by replicating that or moving it anywhere in the device you want. So that lets you create a PR stream once and reuse it. But also the way that this works is because it's connected to that 2D NOC, you're really just manipulating the address at which that IP lives. And we give you software within our ACE development environment, a software tool to actually do that without needing to customize and recompile every time. So huge advantage. If you need to learn more about the 2D NOC, we have an introduction training to the 2D NOC as well. So we'll do this granularly. What we'll do first is I want to give you kind of the 10,000 foot view of the process. Then we'll go one step deeper, and then I'll actually walk you through each of the steps. So step one is I've got to create a partial reconfiguration bitstream for the first what we'll call partial reconfiguration core A. Think of it as the first function that I want to control. Then I'll need to create the second function, so what we'll call partial reconfiguration core B. I need to generate that bitstream. And then the third thing I would create is the overall design that then uses what we call the top level design that's going to use those that partial reconfiguration keep out region that core A and core B will be swapped in and out of. And that's kind of what the last step is. You run the FPGA, power it up, and then you load it with either function A or function B. And of course, you can dynamically swap between the two as needed. So let's dive to that next level deep. These are kind of the steps you're going to use to generate a partial reconfiguration for these different partial reconfiguration cores. And in our example, this tutorial, we're just going to use two, core A and core B, we'll call them. So step one is I have to synthesize the partial reconfiguration core A using the simplify tool. Then within the ACE, the Achronix CAD environment, we're going to run the prepare stage. That'll perform the DRC on the design and transmute that design into an Achronix design that our software can recognize and leverage. Then you want to set up your region and your clock pre-routing constraints. You run your place and route within ACE. And then, of course, you have to validate and sign off on your timing analysis. Make sure that it meets timing and the performance, therefore, that you're expecting. You set up the bitstream cluster mask and the partial reconfiguration options. You generate the partial bitstream, and then you're going to save the region and clock pre-routing constraints back to a PDC file. And again, we'll go through each of these steps in more detail. But those first, let's say, 8 steps are what need to be done for every partial reconfiguration region and core that you're going to build in this design. So you would repeat these steps for each core. In this case, we have 2 cores, core A and B. The first 8 steps generated core A. We'd go back and do that again for core B. And then we'll create the top level design bitstream that includes those 2 cores. Right? Keep out region that we can drop those 2 cores in. And then, of course, the last step is to program the FPGA with the respective bitstreams that we want, and we test to make sure that they all work. So let's dive to that next level of depth. Let's walk you through each of those steps in detail. So the first step we said was to synthesize the design. So that's where you're going to write your RTL for the IP that you have and for that function you're creating. So you create a simplified project with all that RTL, all those RTL files included in it for that partial reconfiguration core. Once you've done that, you're going to run and compile the design in Simplify. Right? So that will actually synthesize the design. But now we have to bring that synthesized design into the Achronix CAD environment, ACE. So we'll create a new project within ACE. We'll add in all those source files and constraint files that we just create, the output of Simplify, but also we have timing constraints and pin constraint files, PDC, that we can include at this point. It could be a dummy because maybe you haven't done the top level design and you don't have all your pinouts for all the other IO, or maybe you are leveraging a design and therefore you're just going to swap out one of the functions. So you already have your top level PDC file in there. So however, you just make sure at some point you'll have to include it. We'll cover that later as well. But now you're just going to run the prepare step in the flow window. So within the Achronix CAD environment, down in this flow window, you'll see the first option is prepare. You can either double click it or just right click it and select run selected flow step. Next, we're going to set up the region constraints. So we have to create a partial reconfiguration region to put those cores in. So from within the ACE software, we can go up here to the menu and select this little icon here. That's the floor planner perspective, and that will open up all the appropriate windows to floor plan the design. So within the floor planner window, you'll see this placement region tool. So we'll select that and then drag and drop to select, left click, I should say, and then drag and drop to the size of the partial reconfiguration zone that you're going to create. Make sure it's big enough to hold all the IP, all the different sizes of the functions you're going to drop in there. Again, remembering that it has to be on a cluster bound. So when you do that, when you release after drawing that box, it'll pop open a create placement region pop-up window. And within there, the first thing you can do is name it, right? So maybe you have multiple regions in here, and each region has 3 cores that you're going to put in there. I mean, you just have to make sure they're uniquely named. So in this case, we're just calling it something generic. We're calling it PR zone 2 to 7. But then you want to make sure that you have your region alignment set to snap to fabric clusters. That's the lowest granularity that we can select because, again, it has to be on the bound of the fabric cluster. Then for under region type, we want to make sure it's selected to inclusive, and that'll constrain all the instances to that region that we're creating. We want to include the routing to ensure that all routed nets are constrained within that region, and then we want to make sure we identify it as a partial reconfiguration zone by selecting that option. The next thing we're going to do is we need to add all the instances in the PR core to the region. So we want to make sure we assign, in this case, we're still creating core A, right? We want to make sure that we assign that to that partial reconfiguration keep out zone that we just created. So the way you do that is you run this tickle command line, add region, find instances. We're going to look for the PR zone 27, the one that we named in the previous slide. We're going to look within that PR to find this IPR core 1A instance. So this is, in this example, is the top level PR module that we're using for core A. Now, in the GUI, we'll drag the PR core module in the netlist browser over to this PR region that we created, and that actually issues this tickle command. And the floor planner tab should now show a red bounding box because we just created a PR zone. So that'll change that color to that bounding box to red. Now we're going to navigate to the placement regions view. So within that window, there's a placement region view. In the floor planner perspective, you're going to select the configure clock pre-routes by right-clicking on the clock pre-routes tab, and down here you'll see the configure clock pre-routes option. That will open up a dialog box where you can select the net of the name of your clock that you're going to assign. Each design will have potentially multiple clock domains. So you need to make sure you're assigning each clock in your top level design to a particular clock track to connect things up. Now we want to go back to the project's perspective. So again, we'll click this little icon in the top of our ACE environment window to switch back to the project's perspective, which gives us, again, all the files we've added. But then down below, you'll see after we've run prepare, it's got a little check mark next to it saying we've done that phase. Now we want to run the place and route. So again, you can double click it or right click it and select the run selected flow step. Now that we've run the place and route, when that completes, we need to do the design completion step. So we'll right click or double click on that to run that within the design flow window. Now we need to get in and actually go back to that floor planner view. And we want to set up the kind of the bitstream cluster masks and all our PR options for this PR zone that we've created. First step is under that placement regions to select visibility. And then what this is going to do is it's going to calculate a cluster value that we're going to use, and you'll see this on the next step. But this cluster value that's going to get configured. So it basically indicates which cluster is going to be occupied by the PR zone. So it has to have a particular value. When the Bitstream PRC cluster map implementation option is set, that will generate a partial reconfiguration bitstream for the clusters in that PR zone. So this little icon over here next to that partial reconfiguration cluster value will actually send, it's the send to tickle command is what we'll actually click to set that cluster value, that implementation option. So if we switch back to the project's perspective, again, clicking the little icon in the navigation window, under the options sub window, you'll see the bitstream generation that you want to expand. And then you want to go down to enable partial reconfiguration. And you want to make sure that this value maps or matches what you just did in the previous step, right? So it needs to be set to the same thing for this partial reconfiguration region. And the last thing would be to lock the FCU after programming. So once we've programmed it with this PR, we want to make sure we lock it so that everything's connected, locked, and not being reconfigured. Now we're going to generate a partial bit stream. So we've gone through the design, we've checked the timing. Now we're going to actually program the FPGA by generating a bit stream. We're not actually going to download it and program the FPGA. We're just going to create the bit stream that'll allow us to program core A into that PR zone that we created. So we'll go down here to the FPGA programming, right click, and select run selected flow step, or you can always double click. But you want to make sure that the FPGA download option is deselected, because we're not going to try to program the FPGA yet. We're just creating the bit stream to reconfigure that PR zone. So the last step for creating a PR region is to save the region in the clock pre-routing constraints. So if we go back to that floor planner perspective, under the placement regions tab, we're going to click this little icon over here. It's save placement regions button. This will actually save the PR zone region constraints to that PDC file. So when you select that, it opens up a window, and again, you can automatically add it to the project and save the file, the PDC file, to the project. In this case, we're under Core 1A. That's the PDC file for Core 1A. ACE will automatically generate a file with the clock pre-routes to the output area, which needs to be added to that ACE project. So that's why it's just easier just to click automatically add to project. So step 9 is to repeat. So we're going to, if you have, in this case, we did Core A, we need to go back and do this all again for Core B. So we would repeat those previous steps for that next Core B to target that PR region. So that would all get done again for, again, Core B. We've already created the keep out zone. Now we just have to go back and map our new IP for Core B to that region. And again, if there were 3 or 4 of them, you could have C and D, and maybe you have multiple zones that you're adding multiple PR cores to, but the idea is the same, to create that PR region and assign the cores to it. The next step, step 10, is we have to create the top level design. So that top level design that's going to use the PR cores within those PR regions or zones. So the first thing we have to do is bring in the respective clock for the PR region, because we have to clock or the logic. So we'll create a new IP configuration for the clock IO bank. We'll configure the clock IO bank for the PR core that we're using. Then we'll configure the PLL for the PR region, again, creating new IP configuration for the PLL, then configure the PLL specs, and then configure the NOC for the PR region. Again, under the IP window, we can click new IP configuration for NOC, configure the NOC for the PR cores. And then again, we can go back and say, because this is our top level design, we might have other clocks we need to do, other PLs, other logic that needs to be connected to the NOC, maybe DRAM, GDDR6, Ethernet, PCI Express. I mean, all the different IO interfaces that we're going to need in this design, we could specify now in the top level design. So think of the top level design as the wrapper or your actual FPGA, where outside of what's going to be hot swapped. So we're going to generate the IO ring design files and ensure that the add to active project is selected. Right? So we showed you that on the previous slide. Now we're going to synthesize the top level design and simplify, because again, we've created a top level design that's going to use cores 1 and core A and core B. So we have to go back to simplify, create the top level design in simplify, synthesize that, go back to ACE. We're going to create a project in ACE for that overall design, right? Add all the IO ring files that we've created previously, configure the options for the design that we need, and then you're going to go through the prepare phase for the overall design. So again, now this will include all your constraints files and all the different IP blocks that you've synthesized. Now we're going to make sure to set up the keep out placement regions. So in Floor Planner, we're going to view the placement region tool again, right? You're going to create the keep out region for the PR cores in the top level design. We want to make sure it matches what we did when we created the PR region and the cores in the previous steps. So we're going to do this because now this is a new design, all new design files. We're going to map everything to it. So we're going to create that PR region again, like we did before. Snapping to fabric clusters, giving it a unique name. But now we're going to select keep out for the region type, because we're not going to put any logic. These are keep out regions. And again, I have maybe multiple, right? because I want to make sure that when it routes the overall design around these partial reconfiguration regions, that it doesn't try to put logic in these spots where we're going to be dynamically reconfiguring them with different functions, these PR zones. So we'll need to do all that, and then if there are multiple PR zones, right, we'll do this multiple times. So we got to, again, pre-route the clock net to the partial reconfiguration keep out region. So in the floor planner window under the placements region, we'll right click again on the clock pre-routes, go down to configure clock pre-routes. And then in that, we'll pop open a window where we can assign a clock net to that respective clock for this region. Then we'll go back to the project's perspective. We'll run the place and route in the flow window for the overall top level design. We'll then go through the next step, run the design completion step. And then the final, again, to generate the bit stream from the flow window. Now, again, we're going to want to make sure we select lock ECU after programming, as shown here in the bottom, and save the region in the clock pre-routing and placement constraints to that PCC file, just like we did before when we did it on each individual one. Now, we've basically built an FPGA with some keep out regions, and we already have the bit streams that we can load into those partial reconfiguration keep out zones. So what we want to do is program the FPGA. So we'll power on the board. We program the top level design, because that's the design with the keep out regions that have the PR zones that we're going to be hot swapping. So we program the top level design's full bit stream. Again, here are the tickle commands that you can do to run that individually. Then we're going to program the PR zone with the first code. So in this example, what we're going to do is say, okay, I'm going to take that PR code for core 1A or core A in our example, and we're going to tell the tool program our keep out with 1A. We run the system, we test it, we make sure it works correctly, and then we can reprogram that PR zone with a different example. In this case, it would be 1B, and then we run and test the system. So again, high level, I know that's a lot of stuff to try to absorb. There's a nice, within ACE 9.0, a nice tutorial that this is based on that comes in the design in the example subdirectory called partial reconfiguration. And you can walk through this tutorial on your own in more detail. In the documentation, includes a very similar but even more detailed step-by-step to go through and build an example. But also there is on our Achronix support portal a reference design for kind of that next level of depth of using real logic that you could do something real with in the design and get started with. So the tutorial kind of walks you through the process like I tried to show you here today. And the reference design is a real design that goes a next step deeper that you can actually use as the basis for your own design. So again, on the Achronix portal, you can get access to that. So that's it. So I wanted to say thank you for your time. Thank you for listening through. I know it's a lot of information. Please check out some of the other trainings if there's something that was of interest to you that is new to you. And if you have any questions, don't hesitate to reach out to us. Thanks again.